So here is my next 6 minutes. So far we've covered counting, understanding of negative numbers, fractions, real numbers, infinity between two numbers, exponents, logarithms, and understanding the visual representation of algebra, geometric shapes, concept behind triangles and circle and so on and so forth. Now all these naturally lead us to what happens when a variable changes or multiple variables changes in our real world. Right now as I speak, the time changes, the temperature in the room changes, the speed of the fan changes, so on and so forth. Now, this all presents us with a lot of data, so an understanding of statistics becomes important. In statistics, there are useful metrics such as average value that is possible, the most common value that is possible, or the median, or the mode, or the variance from the mean, or standard deviation, so on and so forth. These are not just formula, but they have an additional meaning. They are trying to convey you, crunch you the data, and give you a key metric that you will use to solve specific problems, such as following: what is the probability of a certain event occurring that is closely connected to this particular statistics? The number of possible outcomes have a reflection towards what is the most likely outcome that is possible, or how likely is a certain event possible to be favorable, not just for gambling but to make most business decisions. This is a very useful metric. Random variables, you associate them to a limited subset or a set of spaces and you distribute them over another function. You treat a probability as a function and you enjoy how it changes over multiple dimensions. When dimensions come, vectors naturally come together, because vectors are nothing but I, j, k or x, y, z are the amount of growth or reduction possible across multiple dimensions. And why matrices are useful here is because you perform vector operations like solving a particular equation or understanding the statistics using multiple dimensions. You can use digital hardware to simplify these computations, multiply, accumulate. Therefore matrices become important. Naturally leads us to studying change. When a particular dimension there is a change, what happens? You study calculus. In calculus, you are worried about an instantaneous change of a certain phenomenon. The best way to understand calculus is to think about physics. In physics, an object, let's say stationary, its displacement is zero. It is not moving at all. Now, what happens to its velocity is the rate of change of displacement. You do ds by dt, it is also zero. It is not changing. Let's say this displacement was at a constant place 5 units from the origin. You are not changing the velocity at all. What happens to acceleration, which is the second derivative of velocity, which is also zero? Now, on the contrary, when there is constant velocity, when there is a uniform velocity or a specific number, let's say 3 meters per second, draw an x-axis and a y-axis. In the plot velocity, mark 3 and draw a straight line parallel to x-axis. Now understand, draw the equivalent graph for displacement. You see that there is a uniform distance will be changing because the object is not stationary anymore. It has a uniform velocity, so the distance will change uniformly. It will be a straight line going through the origin and it will have the slope of that particular velocity. The slope of the displacement curve against time is same as the value of velocity that you originally started with. And what is the acceleration? Now you have a uniform velocity, so there is going to be no acceleration. So if you differentiate that, you will get 0. Now go reverse again. Let's assume that there is an acceleration, a uniform acceleration of 9.8 meters per second squared towards Earth. So you draw a line, you draw x and y axis. X axis is time, y axis is acceleration. 9.8, draw a line parallel to it. Now figure out what would be my velocity change. It would change 9.8 per the slope of 9.8. So every second there is going to be an increase in velocity of 9.8. And how will my displacement look? Parabolic, that is where your half 80 squared comes. So S is equal to ut plus half at squared should not be a formula introduced to you when you are in 6th standard or 7th standard. It is when you beautifully understand how calculus brings this parabolic effect of constant acceleration to a uniform sloped velocity to a parabolic increase in distance as time goes. That's the beauty of calculus. Now, what is integration? You actually do the reverse of this. You accumulate small changes of displacement, small changes in velocity, you will come to displacement. So you integrate velocity, you will get displacement. You integrate acceleration, you will get velocity. It is nothing but you are accumulating small changes of what is happening instantaneously to arrive at the original variable. Trigonometric calculations often have calculus in them because they are easy to solve. They have equal growth in two directions, positive and negative, so they cancel out. They are very easy to solve, so you'll find them often in trigonometric equations.